So all of you, welcome back. Now we'll start the class of random variables. Conditional probability. So conditional probability is a very important topic for the probability questions, because definitely for EC students, and mechanical students, you'll be getting the questions from conditional probability. Okay, most of the time. And now let's do these questions, my dear. Let us understand this concept first of all. So what this concept is, that here suppose two events are happening sequentially, that means one after the other. So in that case, if I say that A happened, if A happened, so if is a conditional, so if A happened, then the happening of B. So here it is that, so after happening of A, so you are taking the happening of B. So here, when if probability of A is given, then you are taking the probability of B. As B is happened after happening of A here, so therefore here when he mentioned that if P of A is given, then the probability of B, means it is very clear that we need to find the probability of B with respect to the probability of A. That means we need to find the probability of B considering that A is already happened. So you are finding the probability of one event with respect to another event. So that becomes the conditional probability, my dear. So that is what here it is. So the probability of B you are finding is nothing but the conditional probability denoted by P of B by A. P of B by A. So we call this B of B minus A in many ways, like the probability of B given that A happened. Given that A happened. Or if P of A is given, then the probability of B, that is also given. If A happened, then the probability of B, that is also here. P of B by A only. So this many ways we can read that P of B by A and we can understand it. So this is the conditional probability beta. Similarly here, suppose if B happened. Suppose if B happened here, so then the probability of A is the conditional probability. So then the probability of A is the conditional probability denoted by P of A by B here. Now see here. So B, if B happened here, that means considering that B is happened, you are finding the probability of A. So you are finding the probability of A considering that the B happened. So that means you are finding the probability of A conditionally, not unconditionally. So you are conditionally, you are finding the probability of A. So that is, we write it as P of A given that B happened, or the probability of A when P of B is given. So like that, many ways you can understand here. So this is what the terminology of the conditional probability is basically. Okay, and you can understand this way. So now, my dear students, I'll go for the multiplication theorem. चलो बेटा हम देखते हैं conditional probability here. So conditional probability here. So conditional probability here it is multiplication theorem. So here in the case of conditional probability here, it is very clear that we are finding the probability of B considering that the probability of A. So that means A and B are getting dependent here. A and B are getting dependent events here, because we are finding one with respect to other one. So therefore it becomes a dependency. It becomes a dependency. So then here the multiplication theorem is given by like this. It gives you the probability of A intersection B. What do you mean by the probability of A intersection B? So it is the probability of both A and B here. It is the probability of both A and B. So when you want to find the probability of both, so you need to multiply according to product rule. according to product rule. So we want to find the probability of both. So that means we need to multiply their probabilities. Suppose if A happened first, so it is probability of A into next the probability of B. So as the next probability of B is nothing but the conditional probability, it is B by A. So therefore it is written as P of B by A is equal to here. Now suppose if B happened first, so then it is written as P of B into next you have to multiply with the probability of A, but this probability of A is getting conditional, that's why it is written as probability of A by B here. So this is what the multiplication theorem. This is what the multiplication theorem. You understand, I think, here, right? So I hope all of you are clear. Yes, everyone? Yes, beta. So we have to do the questions using this thing only. Now from this multiplication theorem, see here, from this multiplication theorem, P of A by B is can be written as P of A by B is given by P of A intersection B divided by P of B here. This is what P of A by B. Now next, similarly, P of B by A, suppose here it is a conditional probability. P of B by A is given by P of A intersection B by P of A here. So these are the formulae we use to find the conditional probabilities, and this is the formula we use to find the probability of A intersection B here. But multiplication theorem is a very, very important one, okay, to give the conditional probability, to do the conditional probability questions. Chalo. For the rest of the 1 hour, I am going to use only this. Okay, so now we are moving on to questions on this concept of multiplication theorem and conditional probability. So all of you are ready? Yes, next we'll do, okay, we'll start the questions on conditional probability from the question number 21. So let's do the question number 21 here. Yes, all of you please read the question number 21. Okay, so the question number 21 is, a pair of dice is thrown. So this is the experiment. Find the probability of getting sum 7 when it is known that the digit on the first die is greater than that of the digit on the second die. Okay, so now let's do this. Okay, let's do this. Okay beta, chalo, question number 21 beta. The experiment is what? That is, a fair die is thrown twice, or a pair of dice is thrown, right? Is the same thing, na? A pair of dice is thrown or a fair dice is thrown, whatever it is. So this one, the sample space becomes, it is 6 into 6, it is 36 here. So this is the sample space, my dear. Now what is the event E for which we need to find the probability here? The event is that getting sum 7, getting sum is equal to 7 when the digit on the first die the digit on the first dice is greater than the digit on the second dice. The digit on the second dice here. So this is the event here. But dear students, it is a conditional probability or not. See, we have to find out the probability of getting some 7 when under the condition. Yes, what is the condition is that? The condition is that the digit on the first dice is greater than the digit on the second dice. Is the digit on the greater than the second dice here. So therefore, here I can say the probability of E is given by the probability of, yes, it is a conditional probability, right? What is the probability? He is asking the probability of getting some 7. So it is the probability of sum is equal to 7 when condition. What is the condition is that the digit on the first die, the digit on the first die is greater than the digit on the second die. That means the first digit must be greater than the second digit. He is saying that the first digit is greater than the second digit. He is saying that under this condition you have to find a probability of sum is equal to 7. So this is what the exactly the conditional event which is asking the probability, right? So that it becomes a conditional probability. Now dear students, how to evaluate this here? Now let us understand this is A and this is B. So the probability of A by B is given by what? So probability of A by B is given by probability of A intersection B divided by probability of B. So therefore, so this is given by the probability of A intersection B. So that is sum is equal to 7 and sum is equal to 7 and the digit on the first die is greater than the digit on the second die. Okay, divided by, and the probability of the digit on the first die is greater than the digit on the second die. The digit on the second die here. Okay, beta. So this is what the way you have to write the probabilities. First of all, according to the conditional probability definition. So now the probability of sum is equal to 7 and right. So you have to see this. The first will let us look into the denominator first. Denominator first. What is this denominator? Please see here. It is the probability of the first digit greater than the second digit. So we need to find out the probability of the first digit is greater than the second digit when a die is thrown twice. So दो बार थ्रो कर रहे हैं, दो बार थ्रो कर रहे हैं, तो दो बार थ्रो करने से पहला एक आएगा, दूसरा एक आएगा. So first dice, second dice. So first digit, second digit. Now here you should see that the digit on the first dice should be greater than the digit on the second die. That's what he is asking the event is. Okay. Now, my dear students, let me discuss this exactly this experiment. What happens in this? When you die, when you throw a die for 2 times, so you will get totally 36 combinations like 1 1 1 2 1 3 1 4 1 5 1 6 up to 6 1 6 2 6 3 6 4 6 5 6 6. That means totally 36 combinations you will have. In these 36 combinations, please observe that 1 comma 1 2 comma 2 3 comma 3 4 comma 4 5 comma 5 6 comma 6. So there are only 6 possibilities where the equal digits you get it. So 36 minus 6 will give you unequal digits. Okay, unequal condition. Equal are 6 removed, so that you will get unequal. Unequal cases are 30. Now dear students, if 1 comma 2 exists, 2 comma 1 also exists. If 4 comma 5 exists, 5 comma 4 exists. So if greater than exists, then less than also exists here in this combinations here. So therefore here I can say that these 30 number of unequal possibilities are equally divided for greater than and less than. So less than के लिए जितना होता है, greater than के लिए भी उतनी होगा. So the 15 for greater than and 15 for less than. So therefore here the favorability for this condition is here for this event is 15 out of 36. 15 out of 36. And then coming to this one beta, probability of sum 7 and also digit must be greater than. Yes. Now what are the possibilities of sum 7? Sum 7 means, 6 possibilities you get. So I told you, in these 6 possibilities, for getting an odd number, so for getting an odd number, you won't get any equal cases like 1 comma 6, 2 comma 5, 5 comma 2, 1 comma 6, 6 comma 1, 1 so 2 comma 5, 5 comma 2, 4 comma 3, 3 comma 4. So you will have a 6 possibilities, my dear, right? These 6 cases are equally divided for greater than and less than. But here we have the events which are giving you sum 7, and also they must be satisfying this condition, this event also. So here, so what are the possibilities which satisfying both the events? So the possibilities for both the events here is nothing but 6 comma 1, 6 comma 1, and 5 comma 2, and 4 comma 3 here. So sum 7, sum 7, sum 7. Here it is greater than this, it is greater than this, it is greater than this. So out of 6, so greater than will be 3, less than will be 3. But we don't want less than, we want greater than. So the events in which the first digit is greater than second digit, whose sum of the face values is getting 7, is this event. So dono satisfy karna hai. So both are satisfied by only these 3 out of 6. So therefore, so 3 out of 36 is divided by 15 out of 36. So this will be of 3 out of 15. So the answer will be 1 by 5. Good, very good. Chalo, next beta, next question. So we will go for next question. That is question number 22. Now, if anybody have any doubt in this question, anybody has any doubt in this question, you just see it. Intersection means, A intersection B means A and B both should satisfy. The events which satisfy both A and B, so that they comes under the favorability of this numerator. So these are the 6 comma 1, 5 comma 2, 4 comma 3 are the only 3 cases which satisfy sum is equal to 7, and as well as the first digit is greater than the second digit. So therefore here 3 out of 36 combinations, here 15 out of 36 combinations. So 3 by 15 is 1 by 5 is the answer. 1 by 5 is the answer here. Okay. Now moving on to question number 22 here. Question number 22. Right, beta. A fair coin is tossed 3 times in succession. Right? 3 बार एक के बाद एक कार्ड ड्रा कर रहे हैं, थ्रो कर रहे हैं. Right? If the first toss produces a head, then the probability of getting exactly 2 heads in 3 tosses. Okay? Getting 3 tosses. So here you my dear student. So here the experiment is that tossing the coin, fair coin na, yes, fair coin 3 times successively. So this is the experiment beta. एक के बाद एक कर रहे हैं, right? And now the event E is equal to, what is the event for which we need to find the probability? Is that find if the first toss is head. If the first toss produces a head, so the condition is that the first toss is a head. Okay? First toss is a head. E. So first toss is a head. Then what is the probability that exactly 2 heads in 3 tosses? Is it the case? Yes. What is the probability of getting exactly 2 heads in 3 tosses here? What is the probability of exactly getting exactly 2 heads in 3 tosses? Okay. So here, therefore, the probability of E is given by the probability of this. The probability of E is given by the probability of this. So probability of this is given by what? So probability of A by probability of probability of A by B you have to find. Dear students, the probability of A by B means so A intersection B by the probability of B here. So what is the probability of B? What is B is first toss is head. Yes. What is the probability that the first toss is head? Yes, half, because first toss is head means it is the possibility is h. So therefore I write this one as the probability of h. It is the probability of h here. Now coming to first toss is head beta. पहला टॉस जो है head होना चाहिए. That's it. First toss is head. So one time you have turned and what is the probability of head is 1 by 2. So that is probability of head, right? Now coming to the numerator, A intersection B. What do you mean by A intersection B? Exactly two heads in three tosses. And first toss is head. So both should satisfy here. So both should satisfy means exactly two heads in three tosses में क्या क्या आएगा बताओ. Now tell me. Look at these cases, but what are the cases you get it? Please tell me. Exactly two heads in three tosses. Head, head, tail. These are the three tosses, exactly two heads. Head, tail, head. So exactly two heads in three tosses, right? And tail, head, head. So this is exactly two heads in three tosses. Exactly two heads in three tosses here. Hope you understand. All of you. Right. So head, head, tail, 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 tail. But now these are the three cases only you are getting here it is. Right? Where exactly two heads in three tosses. But my dear students, A intersection B means, so both the events should satisfy. So both the events should satisfy means first event is this. But the second event is what here? First toss is head. So first toss is head, accepted. First toss is head, accepted, but here the first toss is not head, so therefore this is not accepted here. So therefore in this case we are going to take the probability of only these two cases. Right, so this one here, so this is what here the probability of HTH plus the probability of HHT divided by the probability of H here. See, it is a fair coin. So fair coin means here the probability of head is equal to probability of tail is equal to half. So therefore it goes to be 1 by 2 cube plus 1 by 2 cube by 1 by 2. So therefore it is of 1 by 2. So the answer will be for that is 1 by 2. Okay, you copy. Okay, yes. Both are there. You copy and inform me when you have finished it. Okay, beta. Subhi Goyal, how to know that conditional probability is to be applied? See, how do you know that the probability of certain event you have to find? Based on the event he is asked, right? Same way, if the event is conditional event, it becomes a conditional probability. As simple as that, right? पूरा रामायण सुन के रामा सीता क्या हुआ मतलब क्या करना है सर गिव ओके Sir, by reading these questions, it's looking similar to previous questions only. For example, 27th question. See, the thing is, my dear Mr. Subigoyal, see, one problem can be done in many number of ways. उसका अप्रोच कभी ऐसा भी ले सकते हैं, कभी ऐसा भी ले सकते हैं. Any way you can do it. So any way you will do it, you will get the answer. But that for that examples, this is an indefinite process, so that we have done that way. But this is not an indefinite procedure. It's a very finite one. So therefore, we could do like this. Okay, mister. Okay, anyway, next question is 23. Let's look at the question number 23, dear. Question number 23 is that an examination consists of two papers, paper 1 and paper 2. The probability of failing in paper 1 is 0.3. The probability of fail and that in paper 2 is 0.2. So given that a student has failed in paper 2, the probability of failing in paper 1 is, see beta, ये conditional बन रहा है. देखो, given that a student has failed in paper 2, let's see this here. Given that he has failed in paper 2, the probability of failing in paper 1 is 0.6 is saying. 0.6 is saying, right? 0.6, right? And he said the probability of failing in paper 1 is 0.2 and the probability of failing in paper 2 is 0.3. So this is the data is given to us. Please see that given that he has failed in paper 2, the probability of failing in paper 1. So under the condition that he failed in paper 2, the probability of failing in paper 1 is 0.6, whereas failing in paper 1 is 0.2 and failing in paper 2 is 0.3. Here it is given. So with this data, so he is asking us to find out what is the probability of failing in both the papers. So both the papers means it is an intersection. So that is P of P1 intersection P2 here is how much? This is the question. So by multiplication theorem, beta. Yes, multiplication theorem gives you the intersection. So the probability of P1 intersection P2 is given by the probability of P1 into the probability of P1 into the probability of P2 by P1 here. P2 by P1. But P2 by P1 is not there. So P2 by P1 probability is not given. So therefore, let us take another formula. So P of P2 into P of P1 by P2. Oh, it is given differently. 0.3 and 0.2. Okay. Yes, beta. ये 0.3 है, ये 0.2. Right, correct. So P of P2 is 0.2 here into P of P1 by P2 is 0.6 here. So this is going to be 0.12 here. This is going to be 0.12. So this is how you are finding the probability of failing in both the papers. That is by multiplication theorem. अच्छा सुबी गोयल. Okay. Okay. Misunderstood. Right. Okay. Done. Okay, fine. Chalo. Huh? Please. Yes, that numbers are given wrong. I have taken in the way. Okay, so question number 23, I think everybody have done, right? So 24 is been done. 25. Let's move on to 25 question, beta. Question number 25. Question number 25. Here, you can see that P and Q are considering to apply for a job. The probability that P applies for the job is 1 by 4, and the probability that P applies for the job given that Q applies for the job. Probability of P applies for the job given that Q applies for the job is 1 by 2. Is 1 by 2 here. दूसरा फार्मूला समझा दीजिए. चलो बेटा बैक जाओ. गो बैक. ये बेटा दिस वन माय डियर. कौन है वो? Yatin beta, see this. I have already explained this concept na. So the same thing I have done there. Here A and B, there P1, P2. That's it. Okay. Yatin, I think you got my point. I have already explained there, right? So you didn't ask over there. That means you have understood that point. The same thing I have used here. Right, beta. So P of P by Q is given as 1 by 2. Now, and the probability that Q applies for the job given that the P applies for the job is 1 by 3. Probability Q applies for the job given that Q applies for the job is 1 by 3. Right? Yes. Now, then the probability that P does not apply for the job given that Q does not apply for the job. So, the probability that P does not apply for the job given that Q does not apply for the job. So, this is what he is asking. P of P bar by Q bar is asking, my dear. So, let's do this question here. So, P of P bar by Q bar. Dear students, so this is P of, this is like, P of A intersection B. Sorry, A by B. I'm sorry. It is like a P of A by B. So, P of A by B is a conditional probability. So, how do you give the, how do you find a conditional probability, dear? So, that is P of P bar intersection Q bar by P of Q bar here. Is it so? Now, this is what? Please understand this carefully. Yes, De Morgan's law. I think everybody knows that De Morgan's law. So what is De Morgan's law here? P of A union B bar is equal to P of A bar intersection B bar. You know this. De Morgan's law. So A union B bar can be written as A bar, complement of union is intersection, and then B bar. So that's what is A bar intersection B bar here. So this is what is going to be P of P bar. No. So what we do is, this is P of P bar intersection Q bar. See, P of P bar intersection Q bar here. Now, with this data, see the P of P is given, P of P by Q is given, P of Q by P is given. So with this data, suppose if I use any multiplication theorem, here. So what happens? P of P bar into P of Q bar by P bar. Right or not? Like this, suppose if I do it by multiplication theorem, if I write this, so you tell me, my dear students, do you have these probabilities? You have this one, but do you have this probability? You don't have. Then how can you find out? So we can't find it here. So therefore, we can't use multiplication theorem and get the answer, right? So I am not going with this. So then what to do now? If I don't apply the multiplication theorem and get the answer, so what can I do? What is the alternate here? That is, yes, using this De Morgan law, probability of A bar intersection B bar can be written as probability of A union bar. So this what you have to write, that is P union Q bar divided by P of Q bar here. So this we can write it as, 1 minus of P of P union Q divided by 1 minus of P of Q. 1 minus of P of P union Q divided by 1 minus of P of Q. So this is equal to what? So 1 minus of, what is P of P union Q here? So that is P of P plus P of Q minus P of P intersection Q divided by 1 minus P of Q. 1 minus P of Q here. Hope you got my point. Yes, right. We have 1 P of P. We don't have P of Q. We don't have P intersection Q. So what we can do is that, please understand what I am trying to say. With the help of this P of P and P of P by Q and P of Q by P, can I have the P of P intersection Q or not? Let's see this, all of you. By multiplication theorem, I think you remember, by multiplication theorem, P of P intersection Q is equal to P of P into P of Q by P, or P of Q into P of P by Q. Any one you can use, right? So now, P of P in the P of P I have, what is P of P beta? 1 by 4. P of Q by P beta? 1 by 3. So this will give you P of P intersection Q. I hope you understood everyone. Right. Now this is equal to P of Q, I don't know. But P of P by Q I have, that is 1 by 2 here. So from these two, I'll be getting P of Q is equal to 1 by 6 here. 1 by 6. So P of P intersection Q is 1 by 12. P of Q is 1 by 6 here. Now these values, if you substitute in this, substitute in now, so this formula will give you what? So this formula will give you, so 1 minus of P of P, that is 1 by 4, plus here P of Q. P of Q is what? 1 by 6, and then minus P of P intersection Q, that is 1 by 12, divided by 1 minus P of Q. What is P of Q is P of Q? 1 by 6. So 1 by 6. So this will give you what? Please calculate this LCM and all. So tell me that. Yes, many of the students have already given this. So this is 4 by 5 beta. 4 by 5. Okay, Yatin. Good. Very good. Yes, beta. Next question, we will go for it. Mubin, are you copying? Mubin. Oof. No. Arnav Goyal. No. Arnav Goyal is asking something. Okay, let me tell you what is that. Oh, this is the maximum. चलो. अर्नव गोयल को डाउट आया कि ये बोल रहा है कि व्हाट अबाउट दिस सी अर्नव सो यू कैन सी दिस बेटा P bar by Q bar is given by here 1 minus of P of P by Q bar. This is what correct. Under the same condition, if you want to find, see here you are not finding the probability of something Q and all now. No, actually what happens, you are finding the probability of P bar under the condition that Q bar. Okay, so under the condition, so 1 minus, P of P bar by Q bar is given by, under the P of P bar under the condition Q bar is given by 1 minus the probability of P under the condition Q bar. This is the logic actually. That what you have written is absolutely wrong. Okay beta, chalo. Next we are moving on to the total probability cases. So let us move on to the questions on total probability. Actually, this question is of computer science students. This question is of computer science. Okay. And for data science also, this conditional probability is very, very important here. The conditional probability when it happens. So when you are finding the probability of one event with respect to another event, that becomes a conditional. Okay. As simple as that in one line. Chalo, we'll go to the next one, that is total probability. Total probability beta. Total probability case. Now in this is a very good topic here. Very good topic, I'm telling you. So, and it is a different one. Okay. Now please understand. And the questions on this one also very easily identified once you know what is that and when it happens. Okay, so in total probability when it happens and what it is exactly, so then you can identify the problems related to it. Okay, done, you're right. Yes, let's start about the total probability here. Dear student, if any event E is happening corresponding to the number of mutually exclusive and exhaustive events of an experiment. Suppose if I say A, comma, B, comma, C, comma, D and so on are the mutually exclusive cases and exhaustive cases. The exhaustive means what? All possible cases of the experiment. Suppose if I take only these three. So these three are the mutually exclusive. Okay, mutually exclusive supposes. Mutually exclusive and exhaustive event suppose. Now, if this event is happening corresponding to the event A, corresponding to the event B, and corresponding to the event C. What do you mean by this, sir? I'll tell you, my dear students, practically, please understand. So that is when this, suppose if, see, when this event is happening, so it may happen when A happens. Or in some otherwise simple lines, I will tell you. So E is there in E is there in B, and E is there in C. As E exists in A, E exists in B, E exists in C. All the exhaustive cases of experiment, suppose. If it exists, all the cases, mutually exclusive and exhaustive cases of the experiment. If E is existing in all the cases, so then in that case, suppose if E is happened, suppose I say E is happened, then you will have a doubt. Okay, as E is existing in A, as E is existing in B, as E is existing in C also. So therefore, if sudden at random C is happened, suppose if C is happened at random, so it means that here it may happen when A happen, because it is there in A. So it may happen when B happened. It may happen when C happened here. So these are the three possibilities, my dear students. So therefore, here what I'm going to do here, that is is happening means, see, when A happens, E happens. So this is one possibility, my dear students. Okay. Now, E happens when B happens. E happens when C happens. E happens when C happens. So these are all the happenings of E. These are all the happening of E here, right? Suppose if you have D also, so then you can say that D and then E and then E, F, C, like that. N number of cases you can write. How many all mutually exclusive and exhaustive events will be there? So for all the cases you can have these branches like. Now this is the tree diagram of happening of event E. It is all the possibilities. This tree diagram consisting of all the possibilities of happening of E. Okay, but here this is happening when A happened, so it is a conditional probability. Now this is happened when B happened, it becomes a conditional probability. This is happened when C happened, it becomes conditional probability. Hope you got my point, right? So now, my dear students, if P of A, P of B, P of C, P of E by C, P of E by B, P of E by A, all are given here. If all these probabilities are given, so then the probabilities of E is equal to what? Then the probability is equal to, I want to find out the probability of this E. Dear students, this branch is giving you the happening of E. This branch is also representing the happening of E. This is also giving you the happening of E. So E's happen either this way or this way or this way. Any one of the way that E and E can happen. So in such cases, if I want to find out the probability of E, so then you have to take that the probability of this plus probability of this plus probability of this. And these are happening one after the other here. So we have to multiply these two probabilities. So probability of A into probability of E by A. Probability of E by A. And what is the probability of this? Is that here the probability of B into probability of E by B, right? Another one, P of C, that is the probability of C into probability of E by C, probability of E by C here. So these are all the each branch. This is the probability of the upper branch and the probability of middle branch, and that last one is the probability of the lower branch. So either this way or this way or this way it will happen. So the probability of the first one is this, the probability of the second one is this, probability of third one is this. But you know, if this happens, these two does not happen. If this happens, these two does not happen. If this happens, these two does not happen. So therefore they are all mutually exclusive. So therefore we do the sum of these probabilities here. So this is called the total probability here. This is called the total probability of here. So this is how you have to calculate the total probability. Yes, Ankit Chahar. Correct, beta. I remember this. At the end of the probability, I do it. Okay? This total probability you have to understand with the tree diagrams, not Venn diagrams. Okay, this is happens with the tree diagram. So you take all the possibilities of E and you can find out the probability of E when all these probabilities are given to us. When all these probabilities are given to us here. So I hope this everything is there in the notes. You need not to copy. Everything is there in the notes. No need to copy, beta. Now therefore what I do is, okay dear students, if all these probabilities are given here, okay, that means these are all probabilities are given here, right? Now if P of E by A is given, then suppose if you want to find out the probability of A by E, then how do you calculate? So now some conditional probabilities here, how do we take? The probability of here A by E. Now please understand this. E by A I know, but I have to find the probability of A by E. So probability of A by E is given by, it is a conditional probability. So I can give this by the probability of A intersection E by the probability of E here. But you know, this probability of E is nothing but, what? The probability of E is nothing but what? Yes, all of you. The probability of E is nothing but the total probability. The probability of E is nothing but the total probability. Right. But how do you find out the probability of A intersection E? By using multiplication theorem. So by using multiplication theorem, I can write P of A into P of E by A by P of E here. Yes. P of A I have, P of E by A I have, so P of E also I have. So this is will give you the probability of A by E. Similarly, can you find out the probability of B by E? What is the probability of B by E here? Okay, probability of B is given by here. The probability, see, E by E is given and E by B is given, and he is asking B by E. So in this case, what we do is, yes, again I apply the same condition, same procedure, that it is a conditional probability. So therefore, it is given by the probability of A intersection B divided by probability of B. But the denominator, you know, it's a total probability. But how do you find the numerator? As probability of B intersection E, it is, we can apply multiplication theorem. By multiplication theorem, we can write this one as P of B into P of E by B by P of E here. So this is what the way you are getting P of B by E. Hope you got my point, all of you. So this is what. So similarly, can you write what is probability of C by E here? Or otherwise, I can say like this also. See, if you want to find out A by E probability, so then this into this by total probability. If you want B by E probability, this into this by total probability. If you want C by E probability, this into this by total probability. If you can draw the tree diagram for the given question or given experiment of this kind, so then the things will be very easily, the things will become made easy. Okay, so this is the way you can write that P of A by E and B by E and C by E here. Okay, so these are called this is what the this whatever I have derived here, so these are called as the Bayes theorem. These are all derived under the Bayes theorem here. These probabilities are Bayes probabilities you call. But in without mentioning any Bayes theorem, so I have derived all these things. So the same way you have to do it in the examination also. In the examination also. Now coming to these are all these things are there in the that PDF. Don't worry, you can take it later. EC students, electronic students, see here. In your communication subject, there is a concept called as ML criteria and MAP criteria. In ML criteria or MAP criteria, there is a concept called as posterior probabilities and priori probabilities. See, dear students, what are the posterior probabilities and priori probabilities? So these are all called as priori probabilities, we call it as. These are all called as priori probabilities, and these are all called as posterior probabilities. Posterior probabilities, because using these priori probabilities only we are getting these probabilities, so therefore they are called posterior probabilities. Okay, so in your ML and MAP criteria, this concept will come. So definitely you have to do well in that particular criterias after understanding this. Okay. डाटा एनालिटिक्स में किया था पोस्टीरियर. यस बेटा, करेक्ट, यू आर राइट. I told you na, in data science the conditional probability is very very important here. Chalo, I hope you have understood this topic here, so which I explained. So now we are going to do the questions on this concept here. Chalo, let us start the questions everyone. So the question number I'll be going for 33. No, wait. Question number 31. Let's go for question number 31. Let's go for question number 31 beta. Let's go for question number 31. See, a student takes a multiple choice examination where each question has 5 possible answers. Where each question has 5 possible answers, he attempts a question correctly if he knows the answer. Otherwise, he guesses at random. Suppose he knows answer to 70% of the questions. Okay, the probability that on a question chosen at random, the student gets the correct answer is... Dear students, what is the experiment? It is very clear. You are the student and you are writing the examination. उसमें आपको out of 100 questions में 70 question का answer आपको मालूम है. You know the answer for 70% of the questions. So, and if you don't know the answer, you start guessing the answer. So, 70% of the questions you know the answer. So, for 30% of the questions you don't know the answer. That means for 30% of the questions you guess. You guess, right? But you know, the problem is that if you know the answer will be correct. There is no doubt at all. But when you guess, the answer may be correct or may be incorrect here. Got it? So now, if you wanted to see the correct answer, if you want to see the correct answer, how it happens. देखो बेटा, he is asking the problem. Suppose if out of 100 questions, if he choose any particular question, so what is the probability that this question answered correctly? That's what he is asking. Question सही होने का probability क्या है? Answer सही होने का probability क्या है? So correct answer होने का probability क्या है? Right? What exactly the probability for getting the correct answer? So let me write this. You know, my dear students, first of all, you understand correct answer can be happen in knowing the answer and guessing the answer. So these are the two mutually exclusive and exhaustive events of writing the answer for a given question. So therefore, the correct answer event, the correct answer is an event, okay, which happens when you know the answer, which happens when you guess the answer, right? So now my question is that here the correct answer when he knows the question, when he knows the answer, right? Correct answer when he guess the answer. So these are the two possibilities of answering the question. So what is the probability of K and what is the probability of guess and what is the probability of C by K? What is the probability of C by G? What is the probability of C by G here? So, probability of K, that means knowing the answer is 70%. 70%, because he said that 70% of the questions he knows the answer, right? So, probability of guessing will be 0.3 because 70%, 30%. So, this is what. Now, what, what is the probability of getting correct answer when he guess? See, my dear students. When you guess the answer, how many options will be there in each question? 5 possible answers. See, every question has 5 options. If every question has 5 options, so what is the probability of getting correct answer? So only one answer, so that means 1 out of 5, right? So here, this probability of correct answer when you guess is nothing but 1 out of 5 here. 1 out of 5. So there are 5 options are there. Out of them, only 1 is the correct answer. So guessing answer will be, correct answer will be only 1 out of 5. That is 1 by 5. Now, coming to this matter. What is the probability of correct answer when you know the answer? What is the probability of correct answer when you know the answer? It is certain. 100% it is correct. So 100% means 100 by 100, it is 1. So this is how you take the probabilities. Here it is, right? This is how you take the probability. It is. Okay, so therefore by total probability here, so probability of correct answer is given by probability of knowing into probability of yes, then it is probability of guess into what is probability of C by G, right? Probability of knowing is 70%, okay, and this one is into 1 plus 0.3 into 1 by 5. So this goes to be 0.76 here. Because correct answer is either this way it happens or this way it happens. So this gives you the probability of correct answer only. This is also will give you the probability of correct answer only. So you will do either knowing the answer or by guessing the answer. So these two are mutually exclusive. So therefore sum of these two probabilities will give you the total probability. Yes, it's funny, right? Okay, beta. So, yes, everyone got the correct answer. Yes, very good. So, most of the people are giving the answers. Wonderful. That you people are able to do it. Very good. Appreciate that. Now, question number 32, beta. Question number 32. Or before 32, let us do 33. चलो बेटा 33 क्वेश्चन करते हैं. 33 सॉरी 33. Now, (33) question, beta. The probability that a student knows the correct answer to a multiple choice question is 2 by 3. Yes, if the student does not know the answer, then the student guess the answer. So the probability of guessed answer being correct is 1 by 4. So given that the student has answered the question correctly, the conditional probability that the student knows the correct answer. देखो बेटा, so he is asking, given that the student's answer is already correct. See that, he said, given that the student has answered the question correctly, it is correctly, the conditional probability that the student knows the correct answer. So what is the probability of knowing the correct answer? So this is what he is asking in this question. This is what he is asking in this question here. Okay. This is what he is asking in this question here. So what is P of K by C? What is P of K by C is asking. Right, my dear student. Right. Generally, the correct answer when it happens, just now we have discussed, correct answer happens, okay, correct answer happens either by knowing the answer or by guessing the answer, right or not? दोनों possibilities हैं. So correct answer when you know the answer, when you guess the answer. So दोनों में हो रहा है, right? So what is the probability of knowing the correct answer is? That is 2 by 3. Right? And what is the probability of guessing the answer is? It is 1 by 3. So probability of correct answer when you know the answer is 100%, that is 1. And the probability of correct answer when you guess is, that is 1. See here, correct answer when you guess. Guess karne mein se, what is the probability of correct answer? See, here there are 4 possible options. 1 by 4 he is mentioned. So guessed answer being correct is 1 by 4. He said that. So these are the probabilities are given to us. These are the probabilities are given to us. Now, how do we find out K by C? If you observe this, we have C by K and he is asking K by C. So it is just like Bayes probabilities, previous Bayes probabilities. So here the P of K by C is given by, yes, first of all, it is a conditional probability. So therefore, it is can be given by K intersection B by P of C here. Now, P of K intersection C is given by P of K into P of C by K divided by here P of C here. P of C here. Hope you understood, right? By using multiplication theorem, right? What is P of K beta? P of K is 2 by 3. P by K is 1 divided by P of C. So P of C means this is the total probability or not. So that is 2 by 3 into 1 plus 1 by 3 into 1 by 4. So this is equal to, here you are getting as 8 by 9. Yatin, if you want to understand the experiment, this is the best process. Okay. Other than this, if you go anyway, so I don't think you will be converging to the right answer. Because the diagram, always the diagrammatic representation of the experiment or happenings is very comfortable in giving the answers. Okay, so now we'll go to question number 32. Question beta. 32. Very good. Very good, Vishwanath. Okay, 32 question beta. We have to finish this conditional probability now. Yes, another 2 problems are there. Let us finish it beta. Right. 32 problem. All of you ready? A screening test is carried out to detect a certain disease. It is found that 12% of the positive reports and 15% of the negative reports are incorrect. Okay, see this very clearly. See, a screening test is carried out to detect a certain disease. Okay, now he said 12% of the positive reports are incorrect and 15% of the negative reports are incorrect. Assuming that the probability of a person getting a positive report is 0.01. Now, the probability that a person tested gets incorrect report is, yes beta, the probability that a person tested gets incorrect report. Chalo, he is asking the probability of getting the incorrect report. Chalo, incorrect report ko dekhte hain. Let us see, my dear students, as per the given data, are you observing it or not? Here, the incorrect report is happening in positive reports and also in negative reports. So, an event which is happening in both the mutual exclusive and exhaustive events of a test of any disease. Generally, if you conduct any test of disease, you will get either positive or negative. In positive, there are incorrect reports. In negative also, there are incorrect reports. So, if I say incorrect report happened, so what comes into your mind? Sir, incorrect report is happened means it may be of positive report or it may be of negative report. So, because incorrect report is happening in both the mutual exclusive and exhaustive events. So, dear students, if any event E is corresponding to A, B, C or mutual exclusive and exhaustive events of an experiment, so then the probability of that E is given by total probability. I think you remember, which is given by the tree diagram. So, the same example, जो वहाँ पर दिखा है, तो उसी को हम इस तरह समझते हैं. Right? This is the way we understand with the given data. Now dear students, look at this. So here incorrect report. चलो बेटा एक बार incorrect report का देखते हैं. Let's see the happening of incorrect report. Incorrect report means, see here, as per the data here, incorrect report is happening in positive reports. Incorrect report is also happening in negative report. So incorrect report is happening in both the mutual exclusive and we can see that incorrect report is happened when it is a positive report. Incorrect report is happen when negative report happen. So this is how I have drawn the tree diagram for the happening of incorrect report. But this we should understand incorrect of positive report. This is an incorrect of negative report here. So the probability of positive report is given as 0.01. So then the probability of negative report is 0.99. 0.99. So what is this one is the probability of incorrect when it is a positive report. That it is given. The probability of incorrect when it is a negative report. When it is a negative report. What is given to us? Is there anything is given? Yes, 12%, 15% he said. So this is 12%, 0.12 and this is 15%, 0.15 here. So this is the data is given. So if you want to find out the probability of this incorrect report, so this is given by the total probability by using this diagram. So by total probability here, the probability of incorrect is equal to, the probability of incorrect is given by here. This is 0.01 into 0.12 plus 0.99 into 0.15. So this goes to be 0.1497. Yes, very good. Very good, Nana. Very good. Very good. You are excellent. So calculation part, I never do it. You do it. Huh? So that's very this thing. Now I'll go to the question number 34. I'll go to the question number 34, beta. 34. I'll go to 34. Now, question number 34. Question number 34. In a given day, in a rainy season, it may rain 70% of the time. If it rains, the chance that a village fair will make a loss on that day is 80%. However, if it does not rain, the chance that the fair will make a loss on that day is only 10% here. If the fair has not made a loss on a given day, then what is the probability that it has not rained on that day? Srikanth Yadav, no beta, we don't have any groups. The Telegram channel is there, na? Medici GS, maths, apt, 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 and English, ENGLISH, English. Telegram channel is there. You can join over there and wait. Otherwise, you can ask me the questions on Telegram. Okay, shall I do one thing? Shall I, for all of you, shall I create one Telegram channel for this batch? Shall I make a Telegram channel for this batch? But there must be only engineering mathematics is to be discussed. Okay? Are you sure? If you say yes, so please type it. But if at least one no is there, I will not go for it. Chalo. Next question. So that we'll discuss later, beta. That we'll discuss later. First, I will do this 34 question. I'll do the 34 question. Yes. In a given day, in a rainy season, it may rain 70% of the time. That means 30% no rain. Okay? Right. If it rains, the chance that a village fair will make a loss on that day is 80%. That means if it rains, agar rain hota hai, so then the village fair will have a loss of 80%. However, if it does not rain, then the chance that village fair will make a loss on that day is only 10%. That means it is very clear, my dear. In a rainy season, on a given day, so it may rain, it may not rain. If it rains, there is a loss in a village fair here. If there is no rain also, there is a loss in village fair. So now you understand, my dear students. There is an event here called loss in a village fair. So the loss is an event here. The loss is an event here. Okay, which happens in both the cases, that is raining and non-raining on a rainy season, in a rainy season. So therefore here the happening of, when you wanted to discuss the happening of rain, loss, see there are two possibilities. When there is a rain, there is a loss. When there is no rain, then also there is no loss. Sorry, there is a loss, right? So this loss, I write it as loss when there is a rain. This is loss when there is no rain here. So these are the possibilities. So what is the probability of raining is? That is 70% of the time. So it is not raining is 30% of the time. And what is the probability of loss when there is a rain? So probability of loss when there is a right? So he is asking 10% and 80% here. So in that, so the probability of loss when there is a rain is 10%, and this is going to be 80% here. 80%. This is the data is given to us, my dear. Okay, this is the data is given to us. Now he is asking on a given day, no loss made on a day. Okay, no loss made on a day. What is the probability that there is no rain on that day? So he is asking that if there is no loss on a given day, if there is no loss made on a given day, what is the probability of no rain on that day? So this is probability of A by B, that is given by the probability of A intersection B by probability of B here. Now this is nothing but, here it is of 1 minus P of L here. So P of L bar is given by 1 minus P of L here. But when it comes to P of R bar by L bar here, P of R bar by L bar, this is P of A intersection B, is given by here P of A into P of B, A by B. Okay, so P of A into P of B by A. So we have written this way by using multiplication theorem, right? Okay, now please students, here I will do like this here. Please see here. Now from this tree diagram, what is the probability of loss? The probability of loss is given by the total tree diagrams. I mean total probability or not. So 0.7 into 0.8, 0.3 into 0.1. So this is going to be 0.56 and 0.03. So 0.59 here, right? Okay, so this is comes to, so P of R bar, what is P of R bar is 0.3, 0.3 into, सुनो बेटा, सुनो यहाँ पर कभी कभी theory mathematical steps are easy, right? But sometimes to understand the mathematical steps, language becomes easy. Let's see that here. The probability of no loss on a non-rainy day. What is given here? You look at this, please understand. The probability of loss on a non-rainy day. I can understand this way. On a non-rainy day, the probability of loss is 10%. So on a non-rainy day, what is the probability of no loss? So it is understood as 1 minus P of L by R bar here. That is divided by 1 minus of 0.59. So this becomes 0.3 into 1 minus of 0.1 divided by 0.41. So this goes to be here 27 by 41. 27 by 41. Please read the question. You are wrong, Hema Malini. Acha Manoj. Okay, good. You are able to do it or not? That's my question. Chalo. So you are asking me the Telegram channel, huh? Okay. So tomorrow shall I provide you? Okay. Tomorrow I'll provide you the new Telegram channel. So I hope all of you understood these problems, my dear. Everyone? Yes. Okay, if you see, with the somebody is asking this, who is that? Aftab Ansari. Aftab Ansari, if you want to go for this thing, so again you have to find L bar intersection R bar, na? So P of R bar, it is no, we know that P of R bar. So P of L bar, no, it's not that. P of L bar intersection R bar by P of R bar. So P of L bar intersection R bar, how do you find out? So L union R. So bar L union R is given by what? So this is, I don't think you will be getting it. Okay, it takes a lot of time. I think you will be getting, you will be getting Aftab Ansari, but it will take a lot of time. So much of calculation and all, but there one na, so we could not use the multiplication theorem. I told you very clearly in that step. So I cannot go for the multiplication theorem because we don't have the probabilities. So that is why we went with the normal addition theorem, De Morgan and all those things. But here we are able to use the multiplication theorem and we can get this complement answer very easily, and you can get it because L by R bar is given. You can find out L bar by R bar. As simple as that. So what is the need of going for that? If you want to go, I don't stop you. Please go ahead. Then you will experience something and then you will come down. Chalo beta. So thank you. Chalo. Yes, Ankit Chahar. I'm happy to listen that. Yes, you are feeling comfortable. And now, so I hope everyone understood these concepts of the conditional probability and all. So though we have taken a lot of time, but everybody is clear with all the questions comfortably you have taken. So if any questions or doubts are there, you can ask me through Telegram also and after the class also. So I will conclude the class now. So most of the people have given that, not most of the people, some people have given the Telegram, about the Telegram channel. Okay, so I provide the Telegram channel, those who are tomorrow. So those who are interested, you can come, you can join the Telegram channel so that we, I will give a chance to discuss each one of you. So you can share your doubts and you can chat with other friends and all. But if the group is misused by you, if I observe in any case, I'm telling you, immediately I will, without any notice, I will leave, I will quit the channel. Sorry, I will cancel the channel. Okay, I'll remove the channel. I just want to simply say that I remove the channel completely. So behave properly and be careful in the Telegram channel before I made it, before you enter into it. If you like it, then only you can enter into it. Otherwise, need not. Thank you, Anshika. Thank you, beta. Thank you. So tomorrow is last day for CSE branch. I don't think. I don't think. Another 6 hours means tomorrow and day after tomorrow till 3 o'clock. 1.5 day. 6 hours I needed. So you calculate according to it. Cakewalk is the smallest word for your maths teaching. Thank you. Thank you, Srikanth Yadav. Thank you. Yes, Pavan. That's what I am saying. Very good. Thank you. Thank you, Rahul. Very good, Nana. I am so happy to listen. Very good. Thank you. Thank you, Ankat. Chalo. Yes, if anybody have any doubts, you can discuss. Tomorrow class timing same. 1 to 5. 1 to 5 p.m. Thank you. Thank you. Thank you, beta. Ria, I told you, na. Tomorrow I will provide the Telegram channel so that you can join and discuss. Okay. How to do effective device. Sekran, only one thing. See, you have already done the class and you have taken a lot of time in doing the problems, right or not? So you understood the concepts and everything. So what I suggest you is that immediately you do the PYQs. Immediately. The same day you do the PYQs and apply the concepts which we have discussed here so that you will be having a very effective studies of all these things. So then... suppose if you have any difficulty, what you can do is that after the class, so take all the points, the important points which we have discussed in the class, something you are learning for the first time or something which is very important, and the approaches and shortcuts and all those things, you should write it on a piece of paper on the same day. So after that you do the PYQs. And once all the PYQ questions are finished, so you come after completing the workbook questions and PYQ questions, so I suggest you to go to test series without any delay. Okay, so you go to test series and complete it, and just let where you stand check yourself. Okay. And after all, so when you go for revision also, so the notes what you have written after the class and everything, so then you can recollect them before going to the examination also. So that way you can do the revision, Sekran. Other than that, not required much. I'm telling you, not more than that it is required. Thank you, Ramnama. Thank you. No, Utkarsh, I won't teach the discrete maths for CS people. There's another faculty will teach. Priya Mukherjee, you can solve all the previous gate examination questions here. There are about 3,000 questions are there in the previous year questions. If you by solving the 3,000 questions only, your time will be finished. Asking third time. Question number 17, calculus. Because we are not. I have given the solutions link, na Keshav. Keshav Gaur, I have given the solutions link. So I think you can look into that. Otherwise, you can see this. See, he's saying that the tangent and the chord joining are parallel to each other. The tangent and chord joining are parallel to each other means their slopes are equal. So equate the slopes, you will get the theta. Once you get the theta you put it in x and y so that you get the coordinate point. As simple as that. It is the, tangent and the chords are parallel to each other. Means their slopes are equal. Solve them, you will get theta. The theta you put it in x and y. That's it. Theory book, Shruti, theory book, you use it for previous gate examination questions. Okay, that's it. That is my advice. But if you find the time more, so you can also solve the questions which are there inside the other than the PYQs. Musantika, thank you, beta. Chalo, welcome. Crazy. Okay, fine. Go to any IIT books, IIT JEE, Utkarsh Anand. Go to IIT JEE. JEE kind only permutations and combinations. Only that book is enough. Algebra topic. In the topic of algebra, you will find out this combinatorics. Utkarsh, are you computer science student? Yes, I think you are computer science student. If you are computer science student, the combinatorics is also there in see combinatorics you will be studying in aptitude and as well as discrete mathematics. Aptitude and discrete mathematics. Thank you, Shruti. Thank you. If you get panic, if you feel panic, you won't complete the things, right or not? So don't get panic. Just have patience and do it. That's it. You will be getting it. Keshav, if you have studied the Rolle's theorem from notes, I think you would have solved the 17th question by your own. Since you have not looked into the Rolle's theorem in our notes, so that's why you could not understand that terminologies.